when you come across integral like this, so to know whether you use integral by parts or not, you have to check this one. So you see here the power of x is 1, there it's what? It's 3. So this means you have to use the integral by part. So if the power here it was 4, then we won't use the integration by parts. You will use the integral, just integrate this one. So that means you have something like f of x prime and f of x like this. So this means this one is derived from this one. So if you have something like x raised to 4, and then at the bottom you have something like x, that means when you derive this, you're going to get 3 something. So this is derived from this one. So here in this case you don't use the integral by parts if the power here is bigger than the power here by 1. Let's see for the other ones. So we have to check this one, which one can we use the integration by parts. So this one we're going to use integration by parts. Reason being, this is 1 power. The power of x is 1 and here is 3. So that means you have to use the integration by parts. We write p for parts, and then this one, the power of x here is bigger than this one, so that means it's by parts. And then the power of x here is bigger than this one, that means it's also by parts. But check here, the power of x here is bigger than this one by 1. So you have to check with this one, it's derived from this one. So if it's derived from this one, then that means you're going to use by parts. So in this case, first thing first, if you derive this one, you're going to get something like 2x here. Let's exclude this. So that means here there is no 2 here. As you can see here, there is no 2. It's supposed to be 2. So in that case you have to divide by a 2. If this 2 does not appear here, you have to divide by it. But if it appears, then there's no need for a 2. So this is how you will do the integral. So another thing is like you can use the u substitution method. You let u equals to, and then you use the du. As you can see, there is 2. So this x is here. So you see this x is also this one. Then this dx is here. So because there is no 2, so you have to divide by 2. So that's why if you are not using the u substitution, you can use this other method that you have to check whether these 2 exist here. If it does not exist, then it means you have to divide by 2. This will help you when you integrate it. An integral of this one is like this. So integral is a reverse of derivative, remember. So when you derive this one, you're going to get something like integral of e, it's e. So you're going to get something like this is the derivative of your integral, which is the same as this one, but because there's x here, but because there's 2 here, then and there's 2 here, because so these 2 will cancel. So that means this Gaussian is correct, this one. So you have to check this thing by reversing the integral. If your integral is correct, you reverse this one by derivative, because an integral is a reverse of derivative. So this is how you have to check when you're doing this kind of functions.